Namaskar, welcome to Exercise Explained. In this video, I would be doing Exercise 8A Numericals, Current Electricity, ICSE 10th Physics. So, in this particular video, it will be from question number 1 to question number 4. The rest of the questions will be done in separate videos, the link for which will be provided in the description. If you like the video, do share it with your friends and consider subscribing to the channel. Starting with the first question, in a conductor, 6.25 into 10 to the power of 16 electrons. So here we have the number of electrons given right here. So I can write that as n is equal to 6.25 into 10 to the power of 16, and since this is number of electrons, there will not be any unit. Flow from its end A to B in 2 seconds. So time is given as 2 seconds. Find the current flowing. So we need to find current. So current is denoted by capital I through the conductor. And the value of E is given as 1.6 into 10 to the power of minus 19 coulombs. So this is the value of E that is given in the question. Now we know the formula I is equal to Q by T. So I would write it as I is equal to Q divided by T. And we know another formula, that is Q is equal to N into E. So I can be written as N into E divided by T. So here I get I is equal to N is given as 6.25 into 10 to the power of 16 into E is given as 1.6 into 10 to the power of minus 19 divided by time is given as 2 seconds. So we get 10 to the power of plus 16 and 10 to the power of minus 19 is 10 to the power of minus 3. So we get I is equal to 6.25 into 1.6 into 10 to the power of minus 3 divided by 2. So we cancel this, 2 8s are 16. So here we get 0.8. So 6.25 into 0.8 gives us 5. So we get the value of I as 5 into 10 to the power of minus 3 amperes. We'll get it in SI unit. So if you wish to convert it to milliamperes, we will be multiplying by 10 to the power of plus 3. So I is going to be equal to 5 into 10 to the power of minus 3 into 10 to the power of plus 3 milliamperes. 10 to the power of plus 3, 10 to the power of minus 3 cancels. So we get the value of I as 5 milliamperes. So we can definitely leave it in amperes because ampere happens to be the SI unit. Since here it is given that the textbook answer is in milliamperes, so I have converted it off to milliamperes. So getting to the next question, a current of 1.6 milliamperes. So I can write here I is equal to 1.6 milliamperes. Now in the previous questions we converted ampere to milliampere, so we multiplied by 10 to the power of plus 3. Here we will be converting milliampere to ampere, so we will be multiplying by 10 to the power of minus 3. So 1.6 into 10 to the power of minus 3 ampere. So this is the value of current flows through a conductor. If charge of an electron is 1.6 into 10 to the power of minus 19. So we need to understand one thing here very clearly. This minus given here is for the electron. So we are just supposed to take the main value of it, that is 1.6 into 10 to the power of minus 19 coulombs. Find the number of electrons. So we need to find n that will pass each second. Each second means time is equal to 1 second through the cross section of the conductor. Now we'll be using the same formula which we used in the last question, that is I is equal to Q by T, or we can write I is equal to N into E divided by T. So we need to find the value of N, so rest of it will be going to the other side. So we get I into T, T which was there in the right hand side denominator goes to the numerator. So I into T divided by E is equal to N. Now I write left hand side as right hand side and right hand side as left hand side. So we get N is equal to IT divided by E. So now that we have got this, we will be substituting the values. So N will be equal to I is 1.6 into 10 to the power of minus 3 into time is 1 second divided by E is 1.6 into 10 to the power of minus 19. I can cancel 1.6 and 1.6. 10 to the power of minus 19 goes to the numerator, becomes 10 to the power of plus 19. So we get N is equal to 10 to the power of minus 3 into 10 to the power of plus 19. I'm not writing 1 here because any number multiplied by 1, this will be plus 19 actually. So any number multiplied by 1 is the same number. So yeah. So plus 19 minus 3 is 10 to the power of plus 16. So we get the value of N as 10 to the power of 16. And since this is number, there will be no unit for it. We will just leave it as 10 to the power of 16. Now getting to the next question, that happens to be the third question. Find the potential difference required to pass a current of, so we need to find potential difference, that means we need to find V. To find a current of, so I is given as 200 milliampere in a wire of resistance. R is given as 20 ohms. Ohm is denoted by this symbol. This symbol name is omega. So 200 milliampere can be written as 200 into 10 to the power of minus 3 ampere. Very important to convert to SI unit. When we convert milliampere to ampere, as I told you in the previous question, we multiply by minus 3. So now we have got this. It's very simple. Straight away we will use Ohm's law. That happens to be V is equal to I into R. So V will be equal to I is 200 into 10 to the power of minus 3 into 20. So V happens to be 2 into 2 is 4. So 4 and then 000 because 2 zeros were here and 1 more 0 from here. 4000 into 10 to the power of minus 3. So 4000 can be written as 4 into 10 to the power of plus 3 into 10 to the power of minus 3 remains as it is, and this cancels. So we get the potential difference as 4 volts. The SI unit for a potential difference is volts. So this was a straightforward, very simple question. Getting to the next question, that is question number 4. An electric bulb draws a current 1.2 ampere current. So I is equal to 1.2 amperes at 6 volts. That means potential difference is given as 6 volts. Find the resistance of the filament of the bulb while glowing. In simple terms, they have asked us to find resistance. Now again we will be using the same formula, that is Ohm's law, that is V is equal to I into R, or from this formula we can write R is equal to V divided by I. So R happens to be, V is 6 divided by I is 1.2. We multiply numerator and denominator by 10. So we get the value of R as 60 divided by 12. Now 12 into 5 times is 60. So the value of R is equal to 5 ohms. So the value of R over here is 5 ohms. So question number 5 onwards will be done in the next video, the link for which will be provided in the description. If you like the video, do share it with your friends and consider subscribing to the channel. Dhanyavad.